the lower side of the upper side of the upper board. You can see that there is a big chip right in the middle. This is probably a processor of some sort. Uh, on the right and left, these are the pins that came out of this board, and the pins actually belong to the lower board. Rest of it, there's lots of small resistors and diodes on top of it, but I did not study this board in detail because most of our issues are related to the lower board, so I'll just focus on that one. This is the back side of the upper board. You can see that on some of these places there are some marks here and there. This resulted from me prying it out of its chassis. So if you want to be careful, you can put some cloth to protect it. The only real threat to this particular board is that it can crack. So do not apply unnecessarily excessive force. Just make sure that you know what you're doing. So this is the main board of interest, and the board that we'll be focusing on, because most of our answers lie in the construction of this board. So if you look at this board, first of all, there is a capacitor that resides over here. Underneath this capacitor, there is an inductor. So, and there is also somewhere in between either a diode or a MOSFET. So it, in the end, it performs as a boost converter. So the voltage that this board gets, it magnifies the voltage to around 60 volt for all these MOSFETs to work on. These are power MOSFETs, and they use the uh, uh, upstepped DC voltage from this booster setup to control the actuator motors. So before we move forward, have a look at these three pins. So these three pins on the right and these three pins on the left, they control the motors that control the changing of the gears in the actual gearbox. And there are some MOSFETs all around the board. So before I move forward, you can see that there are some pins that are coming into this board on different parts. So these pins actually directly connect to the connector at the back, that is the TCM connector. And I was able to find this TCM diagram. It's a generic diagram for the same DPS6 transmission for this one that's applicable to the dry DCT one. So you can see that there's clutch motor 1, clutch motor 2, some sensors here and there, and this is the transmission control module on the left and the right. It's still available on the internet if you want to have a look at it, but the way I utilized it was that I realized that there are 8 pins coming out of both clutch motors. So 3 of these pins, they connect to the phase UVW, and then there are 3 UVW phase for the second clutch motor, and then there are 3 of these pins are Hall effect sensors, and then the last 2 pins are the 5-volt supply voltage and the ground pins. So we'll see in detail how it works. The way it works is that, for example, this is a generic motor diagram where we have 3 different windings. So assume that these are the UVW windings from the last diagram. So the TCM has separate supply to UVW windings, and then these UVW windings, when TCM injects power through them, the motor rotates, and when the motor rotates, the Hall sensors, which are positioned at 120 degrees within the motor, they detect the change in the magnetic field, and that is fed back into the TCM, which is then used by the TCM processor to diagnose, to identify the position of the motor, position of the clutch motor. This is how it identifies how deep the clutch is traveling to engage and disengage. And primarily, this is how it knows where the clutch essentially is. So if you look at all these DCTs, which are the trouble codes, you will see that most of them are related to the TCM not knowing where the clutch motor is, what's the position of the clutch motor. So for example, when it says to P2 at 7A means that clutch B is stuck engaged. So the PCM thinks that it is stuck engaged, but it's actually not. It's just that PCM is not receiving any feedback from any significant feedback from Hall sensors to determine that whether it has disengaged or not. So the last feedback that it received was that yeah, it traveled inside, but even though it injected some power into the coils, it should have redirected back, but it did not get any confirmation from the Hall sensors. So all these codes in the end are related to either the power not getting to these windings or PCM not knowing that based on the Hall sensor data that PCM does not know conclusively the position of a clutch motor. So let's get back to the TCM board that we have. I was able to point out that these are pins, the pins of those clutch motors, the UVWs, the UVW phases for both the clutch motors and also the Hall effect sensor. They all were identified some over here. They will all end up over here. The pin-to-pin contact, I got continuity on all these points. So the first one, the clutch A, well, let's check out the clutch A. For example, you remember from one of the drawings that there are 8 connectors to each clutch motor. So here are your 8 connectors: 1, 2, 3, 4, 5, 6, 7, 8. The one on the right, two of a pair of these pins represent a single pin. This is because these are the clutch A power supply pins, and they needed a larger contact area to deliver effective amount of power due to the limitation on the pin size. So instead of this is one of the good things that they did with this TCM board, because they knew that they're going to use compression fit pins. So they just made sure that there is enough contact area available for the power to be transmitted. And usually we do not have any errors that specifically come out of this, because there is a redundant pin that's already there. But usually the problem that we have mostly originates from here, where we have only one pin. So this is the supply and ground voltage pin, and these 3 are the clutch A Hall effect sensor circuits, and these are the most common points of failure on these boards. So similarly for clutch B, we have these 3 power pins. So in clutch A, there were these 3, and in clutch B, there are these 3 power pins. Similarly, the Hall effect sensor points are over here, 1, 2, 3. So this area in general, if you look at these pins, 1, 2, 3, and this 4, 5, and then 6, 7, 6. So these are the pins if you just want to pinpoint out and just want to fix only a few pins, then these are the pins that you need to concentrate on. The rest of them do not pose enough of trouble. So mostly these error codes that we discussed earlier, all of them originates in this area. So moving forward, I was able to point out some continuities between different points. For example, if you look at clutch B, we'll just take clutch B for example. So the clutch B, especially the power to the MOSFETs, you can see that it connects to all these MOSFETs. So I actually went through most of these context points and tried to draw these lines to find out where each of these MOSFETs connect and how do they work out. So in the end, I realized that for clutch A, the power feed MOSFETs are 6 in total. So these are 1, 2, 3, 4, 5, and 6. Similarly, we have 6 of power B. We have 6 of these MOSFETs for clutch B power feed, and these are 1, 2, 3, 4, 5, 6. Similarly, the 2 motors that move around the gears in the gearbox, we again have 6 power MOSFETs for both of these motors. So for one motor, we have 1, 2, 3, 4, 5, 6. For the other motor, we have 1, 2, 3, 4, 5, and 6 one is under this one, this casing. I also pointed out, I also noted the actual MOSFET models for these MOSFETs that are being used. So all these bucks 765 R2s, they are used for clutch motor A and clutch motor B, and all these QN0406. These are the MOSFET models that these boards are using for the gearbox motors 1 and 2. There are a couple of other MOSFETs. For example, this is the only MOSFET of this name, 2N04H4. This MOSFET is actually part of the power supply circuit, the boost converter. It takes the power from over here, the 12-volt power, it comes to this MOSFET, and then it goes to this boost converter. So if you have generic power failure, then the capacitor, the inductor, or this MOSFET you're looking at. I was unable to figure out what these two do, the Buck 7635-55 MOSFETs. My best bet is that they are providing power supply to the processor that's on the first level, the board that we saw in the initial photographs. So I think that these two supply power to the board above. So this is a very good diagram where it actually describes how these six motors work in tandem to move the motor around in clockwise and anti-clockwise direction, right and left, and using only these six MOSFETs, how this motor works. So let's just look at this diagram where we have these six MOSFETs. We've already seen that all the clutch motors and the gear motors need six of the MOSFETs to work. So let's just say that we have a motor with three windings, U, V, and W, and these are connected to these set of MOSFETs in this aspect. So if let's just say that a microcontroller, which is driving the gates of these MOSFETs, it shuts down U. Where is U? U is the one in the middle, V is the one on the right, and W is the one on the left. So if U is positive and V is negative, it will mean that this MOSFET will be shut, and also since the V is negative, so this one will be shut. So when these two are shut, what will happen is that current will flow from here, go all the way into the U, come out of this V winding, go through here, which is the V1, and then it goes to the positive of the battery. So similarly, on the next cycle, U is positive, but this time W is negative. So it means that again, U will still be shut. So the gate is closed here, so it has a path to flow into U, but this time instead of going to V, it will go to W, go to the last end, and from here it will find a way forward into the positive. So because these two are shut now. So similarly, you can look at here and establish that how it's going to work. So there's only three wires that are going to a motor, and on three of these wires will be used for pushing the current in and out of the motor. Sometime it will be pushing the current in, sometime it will be pushing the current out. So here it's shown as the Hall effect sensors, but these Hall effect sensors are only available for the clutch motors. For the motors that are going into the gearbox, we have seen that they are not there. It uses a separate mechanism to establish whether the motor has traveled all the way to the end or not. Probably some of you guys might be familiar with a small knob that's present on the casing, on the housing of the gearbox. Sometimes if it's broken, then the car is unavailable to engage its reverse because it will not know where to stop. So that is the mechanism that it uses for the main motors. So after that, I'll just go back to the drawing that I made based on the information that I have. I'm just gonna go through this drawing. It's essentially the same drawing repeated for all the four motors. Two of them are clutch motor A, the motor A and motor B, and the two of them are clutch A and power supply, clutch A power supply and clutch B power supply. Essentially, we again have the same setup. We have six MOSFETs that control one clutch, six MOSFETs that control second clutch, one motor and the second motor. The first section is some sort of a boost converter over here. There's an inductor and a capacitor. This is not the right diagram for a boost converter, but I'm pretty sure I'm missing a few pieces over here. So just ignore it, but do keep in mind that if you're looking at the voltage supply issues, you need to focus on this portion only. If you want to find out if you are looking for any issues that has something to do with clutch A or clutch B, I've already shown you the photos, and you can have a better look at this diagram, and this will give you an idea how the power distribution inside the TCM works, especially for the motors. The Q1 and Q2s that I mentioned down there, the Q1s and Q2s, these are the two MOSFETs that are utilized on these TCMs. In the end, I would just like to discuss the testing methods for both type of MOSFETs that we have. Both of these MOSFETs are almost identical as far as the characteristics are concerned. There was minor differences, especially around the amount of power that both can handle. The Buck 765R2 can handle up to 200 watts, while this one, which is QNO 406, it can handle up to 100 watts. Operational temperature rating is from neg 55 to 175, and the operating voltage is around 40 volts. So these high power MOSFETs are relatively, you need a breakdown threshold voltage of the gate to source voltage of around about 3 to 4 volts to test it, unlike the regular MOSFETs where you just touch the tip of your multimeter to see if the gate opens or not. So the way I did was I used a 9-volt battery, and I used this setup, and when I touched the plus to gate and the negative to source, at that time the meter leads connected to these two terminals, they would short out, which would indicate that the source to drain switch is working. So I went through all of my MOSFETs on the board and checked every one of them. I did not find any fault with any of those MOSFETs, which actually is another indicative of the problems that we have, the residual problem that the pins that do not get good enough contact with the board itself, and with the temperature changes, they show intermittent working behavior, and sometimes they're non-responsive. So based on this, I'm just going to go ahead and put my boards back together. I'll just solder the points out, to solder the contacts, and yeah, I should see whether it's working or not. Currently, I do not have a car where I can put it in and see whether the fix worked or not. I just have an old TCM, but I'm looking for a project right now, and hopefully I should be able to test it out sooner. Thank you for watching.
So let's start repairing this module here. The first tool you will need is this screwdriver here, or a wrench anyway, something that makes your life easier for you to loosen these screws that we are going to take out now, okay? Yeah, I use a screwdriver to get faster, come on. It is important to point out to you that before putting this module on the bench, I did 11 software checks. I checked if it could be repaired. We could change this module here, okay? Second step you have to do. It's the first step is you check if the Bracco's motors, they are working perfectly. You can see that these here are running. It's smooth, beautiful. So let's go. I loosened the 4 screws. Now we're going to loosen the housing. We have a slightly different method. You're going to have to use a Tarasha. I use a 6mm. I just need to mark this thread here, mark it. I'm not going to enlarge the hole. I'm just going to mark it so I can go in with a screw. I marked it. I'm going to go in with a screw. Head 10-6. I'm going to take out the filings, and let's put the screw in now. He's going to get in really tight. That's normal, okay? Yes, and it has to be like this. If you make a very big hole, you will have a problem when you force the housing. It will rub the thread, and there will be no strength to open, okay? So I got here at the right end. So I'm just going to give it a little push. Oh, I'm going to give it a little push to make room here. Oh, so I'm going to put the FINA key here, and I'm going to give it a little tap to get it in for me, the key to get in here. Oh, It came in. I'm now going to make a light force with the screwdriver so that it starts to open a space there in this part here. Oh, you saw that it started to open a very quiet space. Oh, it's forcing slowly. You can't put force here. And if you put force, it rubs the screw. So you have to be careful. I'm going to change the screwdriver now. I'm going to take a screwdriver a little stronger, and I'm going to continue forcing with a screwdriver and supporting the screw. Oh, two sides. It started to cause some damage. That just started to loosen the glue. Now I can, with two screwdrivers, put a screwdriver here, and I can put a screwdriver here. And what am I going to do? I'm going to make a force to let this one go. This one. Here in the head, oh, let go. Now I'm going with the key. I'm going to, oh, see what they're making, force arrived. So look what happened. He opened this breach here. Now we are going to work with this screwdriver, and we are going to work with this screwdriver, a Maestina and a thicker one. What are we going to do? We're going to get this screwdriver here. We're going to put it here, and we're going to force it, open a small gap, get in here. It's in. Now I'm going to get the small one. The people who have already messed with the tires, something like that, they're going to have to understand what I'm doing here. Look, a small screwdriver. Look, I'm going to give support to the big one. Oh, beauty. We release this side here. Now we're going to turn around, and we're going to do the same protocol here, guys. Force with the big one, strong on the small one. Small, big one makes force. Big one makes force. Strong on the small one is big. Perfect to open. I wanted to open the mode. Oh, you saw that I was filming here with a little more space difficulty, and you saw that I did it very quickly, right? For you to open this mode, you don't damage the housing. The housing is new without any marks, 100%. Now you see what you have to do. You have to take it out. Let's take this screw here that we put it in, right? Let's take it out, right? Now what are we going to do? Well, let's leave this here a little bit aside. I'm going to leave it here on another table so there's no risk, right? Okay, now we're going to take this capacitor here. How do we take this capacitor? Yeah, you can force him. Can force him. It will come out all ground. But there is a technique to remove it, because many times we have this good capacitor, right? So you can test it later with the right equipment, and you can use it in another mode. I made this tool. It's a tool. It's a feiner wrench. In fact, I grinded it. I tuned it to a point that if it stayed like this, you're able to focus there. Oh, it's going to go inside the eye module. I put it inside here. Oh, and I pull it inside here. I do the same thing. Oh, I put it inside here. I pull it inside. It's, again, you can even make it bigger so she can take it all at once. This one, even for me, was a little bigger, but it ended up breaking the tip. I haven't been doing another one, but it's cool. When she was new, past, she took it off. You see, the Shepherd came out brand new with no damage. Okay, after you took out the capacitor, what are you going to do? You're going to take this little brush and you're going to clean this here. Oh, why? Because here it has one, it's like a little filament capacitor that you took out here. It can then interfere there on the board. So beauty, so here we have already checked the motor. Everything is fine, it's clean, no capacitor. So this here is a part that is ready for us to use in the sequence. After that, let's go. Now we're going to work with this board here. So I'm going to tell you a little about this. This board, there's the processor board, and it's this calibration of the witch motors that are inside the gearbox. It's personal, and this plate, it is calibrated for these motors, different from the motors that are inside the clutch. There they have the roll effect sensors, here not here. And these motors, they are calibrated together with the plate, with the defendant's limiter there. So it is calibrated there when then they arrive at the defendant's limiter. For those who have this, already have this experience, right? So it's calibrated to this plate right here, okay? So this plate, it's calibrated for these engines here, okay? So you can see that there are two magnets here, okay? Two magnets here, and receive is the induction here. Oh, and they send EE, they identify this induction, and then they send the signal processor. Oh, if you observe, they are, if I go down here, oh, they are aligned with the motors, and go down here, oh, you see, they are aligned, then they're in in your office, you take a test, they are well aligned. So let's imagine that and there was a problem with this housing, there was a problem with these engines, and what you want is to take it from an old man and put it here. Most likely it won't work, okay? Why is that? Because they are calibrated for this plate. See, there are markings here. Oh, so let's take this marking here. Oh, there and here. Oh, okay. Oh, the markings, they are different compared to this marking here. Oh, it's not, oh, leave here in the same position. Oh, I noticed that the marking is totally different. Okay, so these engines, they're calibrated by another board. Okay, no, that's not the one here. So always keep the little pair. This housing here with the processor board, this board, come on, this board, this is the processor board, right? This one here, that is the brain of the mode, is this SIM card, the bottom card, which is the card that causes the problem. It is the strength card. So that's what we are going to do. We are going to work on the strength card. This card here, as I have already tested, I have already put it in the scanner. We have already done all the tests. It is a card that is good. This card is good, okay? The problem is on the board, on this processor board, which is the board we are going to work on. We are going to continue now. It's doing the verification, so that way, so come on guys, that's what we're going to do now. We're going to loosen these screws here. So here, you guys, it's of the utmost importance that you take great care when loosening these screws, okay? Because you can't hit the eyes on this board, you can't damage the board. So you have to put the tool carefully and loosen the screws with your hand so you don't hit the board. Okay, now what we have to do is we have to preserve this plate. This plate here is a plate here. It is very difficult to damage. It has this part of, come on, let's think that this one would be the brain of the module. So we have to be very careful about this plate here, and we need to remove it from here. How are we going to remove it? So I created a tool, right? It's nozzle pliers. You notice that I spent the whole part of, and so far it's me. I spent it, right? And I made a little pout there. Oh, and he just takes the little tip, you see, just takes the little tip to facilitate the removal here from this board here for us. You'll see how we do it. Sign her, you notice that she has these, she's chubby, right? We need to find it. We need to flatten these connectors here, all of them, okay? Okay guys, so here we have all this tightening, right? All the connectors, so many of these here, you can see that they are flat there. You see they are flat, all flat. An interesting point, did you guys notice that I didn't take those 3 screws out? I left, now you will understand why. Now what you are going to do now with these loose connectors is tight. We are going to take this board out as we do, and how we do it is, it can't bend, it can force. If you have to force it, you have to go to the connector that you think is not releasing and tighten it so that it releases, and why this? The board here is a processing board, so it's a board that we're not going to discard. Come on, so we're going to start here. We're going to start on this side here. We're going to put the hay wrench here. Oh, and it's going to give it a little push. Oh, you saw that it's moving well, right? You saw that you came back here, now I'm going to turn here. You came back here, now we're going to do the same side here. You came back here too. Now let's see, here you came back a little force. You don't. No, you can't force. Okay, guys, force you ruin the board. Oh, you let go now here. Oh, let go here. Oh, let go here. Now let go here. Hold, put your finger on the board like this. Oh, so that it doesn't, you don't escape hay wrench. Okay, you go, it's like you've been groping, understand? It connected, oh, it came back, oh, without force. Now you take the board, pull it, take a look back, perfect. The board itself, oh, quiet, without damaging the board, perfect. Okay, this is important. Now we are going to put this board in a safe place. We are going to keep it in a safe place. We are going to take out here these screws, these grounding. Now we are going to release, we are going to release these 3 screws here. We did not release these screws. It helped us to return this upper board. Let's talk a little about this board, which is a board that I took from another module, and we will understand a little more about this board, okay? So then, as I already said at the beginning of our video, it's this one here. It's the force plate. It's what really makes things happen, what the load passes through it. So we have here is remembering that we then have a double clutch. This clutch is a conventional clutch with plate and disc. And this module here, it touches 4 motors, 2 motors that are in the clutch and 2 motors that are in the gearbox. The engines that are in the gearbox are these 2 engines here, and these 2 engines here are what's inside the gearbox, okay? Engine 1 and engine 2. And we have here the other motors, which are the motors that, and 2 motors that are the cylinders, which is the motor A, is the kind of motor that sits inside the clutch, actuating the clutch. Looking at the plate. Here we go. Let's see if I can show you, and which are the triggers that activate the clutch, which are the triggers that activate the gearbox motors. Here we are talking about the clutch, and these little guys here, oh, this one I'm showing here, let me take a maximum of one another here. These are the little guys that activate. Clutch to these guys here, these little guys here are what activates the clutch. It's engine 2. So here you have the little guys who activate these little guys here. They are the ones who activate the clutch. Motor 2 is here. These are the drivers of the motor, of the little motor of clutch B are these here. Oh, these here are the guys that drive the clutch. Motor 1, they are inside the cane box. Understand? So come on, clutch A, engine 2, clutch B, engine 1. Then when engine warms up, it jumps gear, car no. Gata? Yeah, or it's these little guys here or these here. Okay? So what do you have to do to repair a lot? There are a lot of technical things he does. We used to do that too, right? Well, when I had a problem with the clutch, for example, we would come and change this set. There was a problem with the clutch BA, we would change this set. There was a problem with the fork, we would change these sets here. Then there would be a drive problem, we would change the drives too. But it's this board, it's not just made up of actuators, but capacitors and a series of other components here, and it's in time. because it's left. A lot of it ends up weakening, and this weakens the board. So you changed it here and ruined it here, then you changed it here and ruined it here, or vice versa. So we came up with a definitive solution. Why would you ruin that sign? Because it is a common clutch, a conventional clutch. You have a clutch, people are soot, dirt, and this soot, this dirt, it ends up overloading the actuator carriages, and these actuator carriages, they end up overloading the mode, and then you start to have an overload on the MOSFETs of the outputs here, and it ends up burning, and sometimes it doesn't even, he doesn't even want to, but sometimes he gets cold, he doesn't escape. When you heat up, he starts to escape, and then he starts to conflict within the board, and that's when problems arise. So we came up with a definitive solution to this problem here, not only changing these parts here, and normally what people do EOE is what we did in the past, but changing the entire board. So today we developed a board, and this board comes with ours. Our partner developed it for us, and we replaced this entire board in the module. So we put a new board and keep the processor board in the module. Look, and then all the force load board is replaced in the module. And now I'm going to show you, this here would be the new sign instead, because like that, oh, what did it even have? It's even worth talking about it too. Yeah, we bought the components, and these components often didn't have good quality. It was bad quality. So it's also a problem, because you change this part, put a component here, even if it was new, a bad component, it also caused problems. So the new license plate, it comes to us like this, okay? It comes ready, a new board, checked, everything right, and not only with the output modules. Right, new ones, but like one of the new board, and this is the board that we are going to put in this module now. Good guys, here there are two ways for us to take this board out of place. First way is you cut this head off, cut here, and you force it here, it will let go. I don't like doing that. Why? Because we like to preserve, this original part. So you can, for example, be that you can repair this module and sell it, for example, there in the free market. You can leave the original, does a good cleaning on this housing, and you can paint this module and it becomes new. So we prefer not to take this head off. So how are we going to change the license plate? Then there's no need to remove that head. So we keep the connector head, and we will remove the board, and now we will understand how we remove the board. It's a very simple process to release. Tighten these connectors here again, and then we'll remove them. Come on, check that we've released them all, right? Releasing them all. And then we'll come again with our thin screwdriver. And we're going to push this little corner, understand? And then you're going to run the screwdriver underneath. You saw that it loosened here. I'm here. You have to take care. If you do it differently, you can bend these connectors. You can't fit the new board. You have to unbend. It has to be very careful. It's the same thing. We're going to come back. Let's fucking give 11 clean here to remove this dirt, right? In the dirt, a proper dirt. Let's let the original side lose an originality. Okay, we arrive at the board. What we're going to need this board, we're going to need this one here as a capacitor support, and it's as if it were 11 source. Okay, we're going to need it. Remove this capacitor from the same thing, has 3 clips. We are going to remove these 3 clips with our little tool. People tell me, Flavio, it's what it is and the mode is good. I say, I would tell you it's better than the original because it's original. He's not a soldier, he's just fitted in, right? Yes, and it's often this module here, it heats up a lot for people who stay in one for a long time. In heavy traffic, the car is stopped for a long time, turned on, walking still, so it heats up a lot. So this ends up in a way, it ends up dilating connectors, and it ends up and at some point losing communication, and then you end up having a problem. When we change this plate, we weld it, right? So it becomes a little more resistant. So beauty, guys, take out a board. We take out our strong capacitor. Now we are going to start our reverse work. One side, very careful. This here is an electronic, so we have to take very careful not to hit, not to damage, right? So beautiful people. So here we have our new board. We are going to fit the capacitor support that we took off. Make sure he's okay. Make sure he doesn't have any time off, right? Yes, I like to let him start welding around this bubble plastic because I'm going to use 11 supports here on the key so that he doesn't have the risk of stopping welding this support that won't come out, right? In the correct position, good guys, talking about our welder, this is a welder, he's very powerful, okay? So it's a 70 watt. It would even be interesting to be even more powerful to go to this soda on the power board. And if you put a whole one, it won't create this black residue here. But I ended up not doing this here, always very clean. The tip has to be clean so that I don't fall on the board. Important. I also use this soldering paste here to do some cleaning, some welding. But I don't know if you are seeing the butt, this tip here. Oh, I made it. I made one. I tuned its tip. I made a cut that it fits exactly inside the connector that we are going to weld. I'm going to show it to you now. See what it looks like. It's after welding. I'm going to show you what this plate here looks like. It's thick. I'm going to buy 11 copper plates with aluminum, very thick, so it's not just any welder who welds. You have to have a good welder, and it has to be a welder who really is and can have contact with all the points here. Connector, then my dear, pin on the ground. Gee, look, how did our solder work out? In fact, before it wasn't a soldier, today it's already welded to the plate, right? Or, look, see that she was fine, nothing, right? Well aligned. The form comes, right? Come put it on our feet. This housing on the side as we arrive carefully with all of ours. So here, it's just you and the screws seeing here, oh, verify, this here is right there. You see, oh, controlling the waves. No, everything is right. Guys, tighten, right? Because I'm not tightening the component. I'm here, oh, with my finger here in the middle and here, I'm exerting force here. Oh, seeing, and I want to improve here. So I'm going to tighten these screws here. Oh, the screws too. Oh, seeing, and oh, never tighten the component itself, okay? We're going to leave it here. Here we are going to work with 2 welders. We are going to start first with just this one. And we're going to lock the mode, we're going to lock the door, so everyone work with this welder here, okay? It also comes with his intention to clean the end well. Look, right, see? That here I also made a little hole there. Oh, you see, oh, I made a little hole so that it can grip the connector well, okay? Because you clean it up there, right? It gets better, okay? And we're going to weld this one, we're going to weld this one, and then we're going to weld these here, and then we're going to change the welder. This one is a 50-watt welder that I'm using. Oh, you didn't weld these 2, only damaged? Then you saw that there were 2 left here without welding. Why did I leave it without? Because that welder I used there doesn't weld these 2, so I have to change them. I have to get a bigger welder, which we'll get now. So here we welded the other 2 that are now, we are going to weld these here. These here, guys, are very complex connectors to weld. It has a very thick plate, okay? If you get too hot, you release these components. So you have to be very careful, very cautious. It's not just any welder who welds. It's very difficult to weld this here. Until the first time I did it, it was easy. Then wow, it's immense difficulty. Okay, so just be careful with this weld here. Come on. So we finished the welding of this more complex part. And so, guys, what do you have to understand about this plate here, this structure? Why is it so hard to weld this here? Because it has a very high heat dissipation capacity. This sign, it was developed in the carcass for this, understand? So that the heat that she receives it is released as soon as possible. Not holding the heat is, especially because if she had the ability to hold the heat, it would cause much more problems, understand? So that's why it's difficult to weld. So you have to have the right equipment. You have to be very tight, aligned. That's it, to stay like this, like if you don't have a team. Okay, can't you do that weld? She gets all fucked up, doesn't she? Really fucked up, is it? It's not very beautiful, but it's 100%. Okay, now let's continue now with ours. It's our personal structure. Be careful now when assembling the processor board, okay? First thing, you never forget the grounding in the first assembly I did. I forgot when NM I live. So put all the necessary grounding and go on the board. Put it very neatly here in their proper places, right? Then we will now take the board that we reserved, that we took out for Bulutil first. The board will catch her very carefully. We're just going to tighten the screws so that our name, in the same way that it came out lightly, it has to come in lightly. All the connectors have to fit perfectly here. You're just going to point at him. You're not going to press. You're just going to point at him so he doesn't let go or don't get out. Why doesn't the plate spin in your hand? This board was damaged. Put the other good people here. We put it so the board is, these connectors are virgin. These connectors are virgin. These and these, theoretically, you don't need to solder this. If you leave it like this, it's enough, understand? Those who are relaxed, who are more relaxed, are those from the means, right? This one in the middle, as if you want to find out if a module, if this board has been replaced, if you open a module, you will often solder only here. You won't have it here all over it. And our modules, we just like it. Welding everything. Since you are going to weld everything to ensure, right? Because since we've already welded down there, everything is welded, so why not weld up here, right? Then we'll make it all right, soldier. Now we will put the capacitor and we will turn on the mode to see if everything is right, and then we will complete ADA soldering. So the capacitor, let's talk about the capacitor, okay? It's originally the module takes this capacitor here, which is a 40-volt capacitor. It has 2200 of 2 and 200. This capacitor here is a capacitor that we're going to be using now, which is a 35 capacitor. Only has a greater discharge of 2 and 500. This is all because we made this change in the board and we made this improvement. So we are going to use 11 capacitors that are a little stronger in the discharge. This one originally there, you see, is a little smaller, but that doesn't interfere with anything. The issue of thickness is the same, so we will put these 3 screws here and we'll enjoy it, right? We fell here, you can use one of these. Let's cut off the excess of this connector. Let's take advantage. Let's make a weld in this capital story. Here, positive side. For this side is the positive and negative side, very quiet. Sleep was very inside, more here. Look at the soldier shepherd fixed. You can see very clearly the color of the plate on the new plate in bar. We kept the processor plate on top, and sometimes scheme, always tightening here where there is no component. The board is always well aligned. When connecting this board here on top of the new one, you saw that it took me a long time to align it. I left it very right, and it really goes into the, oh, there, how is it? Oh, you see, everything is fine, connected, everything is right. Now we're going to turn on this mode here to see what it looks like, as we've already removed the capacitor from this one. So just take it here, okay? Now we're going to finish the weld, and then we're going to program it, right? Yeah, not later, I'm going, yeah. You can rest assured that I will. I'm going to show you that the question of how do you analyze the defects, and then we can finish it, okay? Now we are going to weld all this plate here. We are going to weld now on the plate is on the strength plate. Here it is important, people, not to heat the glue too much. AA already take the welder, because this weld, it can go up and down, accumulate in another connector, but they are very close to the other. It is, and can handle it. There are 10 flances, and then contemplate these two. This one, the one that I said is the A20 or the 21, goes together with the good of these flances ours that we manufacture. These flances, they are made of iron, right? And then these plans, you like there was a problem with the connector. You can keep changing the quiet connector, get some aluminum headphones, and you have to condemn flande, right? A suitcase is just a suitcase. Just that kit there from the suitcase there. That kit there comes the suitcase, right? The suitcase is like an organizer. Inside it is very top suitcase. Suitcase is a monster, right? But it's expensive, right? I mean, man, it's not because if you go, it's exactly, there's something like that, like, it's, for example, Touareg, because maybe it's not your audience, understand? And then you'll be there, right? Look, I can pass you, but that's a bit superficial, right? Because, for example, we go for the exchange rate, right? So, for example, take the TEP 72. The TEP 72 will contain up there the Toro, the Accomplice, the Renegage BMW. So a little next year, he releases a car, for example, the Picos itself. Oh, I forgot to mention, right? You also get the Volkswagen line from this kit. So you have a very large 111 line, right? Face of exchange and that. And these exchanges, they can go to one car to another to next year, for example. Understand? It changes the whole feature. I'll pass it to you. Big hug, my brother. He was a soldier, right? Check it out, soldier boy. Then we finish the welding part and plate replacement. We maintain the originality of the module, right? Everything is fine, soldier. Now we're going to finish the assembly like this. Oh, now we're going to talk about the issue of assembly. The ideal is for you to put a glue, which generates one that forms like an eraser, right? I'm not going to use this glue now because I'm using the same original housing. So a glue that dropped here, it's here, so it's drawn. So I just need to create a little layer of rubber, which is enough. So I'm going to use the so-called 3M glue, which you know, okay? It's a glue, it's for engine joints. After it dries, it stays, it turns into rubber, and it really glues, right? So I'm going to use it to make this fixation already, I said. Make sure you put glue everywhere. In this whole part here, do not put excess glue, because this glue cannot enter the module. She'll never get in, because that part of her is shorter than that, okay? So if you put enough glue, the tendency of the glue always goes out and never in, right? I have already done this test on other new screws. I always try to put the screws that were in the correct position, but that is more Sauvignon. What's the average time it takes for you to fix a mode like this? The average time is between 1 hour and 15, 1 hour and 20. It depends a lot on the technical capacity here that we are making this screw. You won't tighten this one You'll just touch it here on the housing, and then you'll tighten this screw here. Then you'll come here. This one is the same thing. Now what are you going to do? You go this excess, you come here. If you've already passed the paper here, oh, don't pass the paper with glue. In fact, the paper will stay there. So you have a way, okay? You will be the glue now, but you have a mode, you don't have any marks, then you can clean it. It improves this glue, right? You can, right? I even put a little too much glue. I shouldn't have put it, but it will be due to the excess, due to the lack of it, right? Now, what are we going to do? We're going to clean this connector. So I'll use rubbing alcohol here, okay? It's if you dirty the board when you weld, you saw that we made a clean weld until you can go back to the video and you see that we made a clean weld. So sometimes when I do a weld that doesn't look cool, it gets half dirty, the tip is dirty in a hurry, so I use this alcohol to do this cleaning, right? So I'm also cleaning this connector here. The look again, huh? And if you're going to paint it, then it stays. Let me drop it here. I'll get a brush here. That's a special high. We use it, right, to clean connectors. Then I'll talk to you straight. Clean these connectors. If you think it's worth passing a paper, something here for me. I use a folder called Regionex Black and the Revitalizer. It revitalizes, right? Black plastic, because I've had this folder for a long time and it never runs out because I don't use it. And in the tent, she doesn't get it, you see? She just stays in black anyway, man. New connector is 0.